Hi folks, let's take a look at page 575, number 4F. So they give us this function here and they want us to find the derivative. Okay, so first of all, just notice the way it's given that the variable, the independent variable is u instead of x. Okay, so I suppose you could rewrite it using x if it makes you feel more comfortable, but I'm going to do it with this given variable. So keep in mind that if I'm going to use the chain rule, I won't be referring to u as my intermediate variable. I'll probably use something like v. Okay, so first thing to notice here is that I've got my two very different functions here that are being multiplied. So I'm going to consider this as the product of two functions. So the product of e to the square root of u times ln of the square root of u. So I'm going to use the product rule first, but of course in finding the individual derivatives I'll have to use the chain rule. Okay. Now when I checked my answer with a derivative calculator, so you should do that online, okay, I noticed that they did rewrite this using the ski-slope rule. So ln of u to the 1/2, which becomes 1/2 ln u, which in some ways simplifies the problem, but it ends up making the algebra at the end a little more complicated. So I'm just going to stick with this function as it is. Okay. So if I want to find the derivative, normally I would just use prime notation, but just in case you want to use Leibniz notation, just have to point out that you're not going to be writing d over dx, but d over du, because again, the variable of differentiation here is going to be with respect to u. So I'm going to take the derivative of e to the square root of u times ln of the square root of u. Okay, so let's start by applying the product rule. So first I have to take the derivative of the first function. Okay, so again, I'm going to use the chain rule, so I'll call that v. The square root of u will be my intermediate variable v. So first I take the derivative of e to the v, which, nice and easy, is e to the v, so e to the square root of u. And now I have to take the derivative of v, which is square root of u. So that's 1/2 u to the negative 1/2. Okay, so that's the derivative of the first function. Of course, now I multiplied by the second function, just ln of square root of u. Okay, plus the first function, e to the square root of u. And now again, to find the derivative of the second, I'm going to have to use the chain rule. So I'll call that thing w. Okay, so first I take the derivative of ln w, which is just 1 over w, so 1 over square root of u. And now I take the derivative of w with respect to u, which again is square root of u, so it's 1/2 u to the negative 1/2. Okay. So now I'm actually going to simplify this out. So I could ask you to just leave it as it is, but I'm going to simplify it out because I want to point out this trick that is starting to be very useful for us when we're simplifying these derivatives, and that's to look for common factors. Okay, so here I have a common factor of e to the square root of u. Okay, but I also have a common factor of 1/2 u to the negative 1/2 in both, so I can move that. And in fact, I'll rewrite this as 1 over 2 times the square root of u. Okay, start simplifying. So what I'm left now after having factored those out is relatively simple. So here I have the ln of square root of u, and the only thing I'm left with here is the 1 over the square root of u. Okay, but of course we shouldn't leave that as it is. We should write this as a single fraction. So let's keep simplifying here. Okay, so here we have to add these using a common denominator. So I'll use a common denominator of square root of u. So I need to multiply that to the first expression. Okay, in the second expression I already have the square root of u in the denominator, so that doesn't change. So all over the square root of u. And now I can simplify a little further. So let's see what we have in the numerator. In the numerator we have e to the square root of u times this expression here, square root of u ln square root of u plus 1. Okay, all over, and what we have in the denominator is 2 square root of u times square root of u. So that's just 2 times, since square root of u times square root of u is just u. There you go. Okay, so that's as far as I'm going to go. But say I did want to determine, some information about this derivative, I have it in the most useful form. Okay, so again, just a couple of things to keep in mind. Here we split this up as the product of two functions, so we use the product rule, and in finding the derivatives, needed to use a chain rule. Okay, notice that here we're working with a function that's given with respect to a variable other than x, so I need to make sure that I interpret my notation correctly. Okay, that's it for this one.